Today's lesson is called Medians and Altitudes of Triangles. So a median is a line segment that connects a vertex of a triangle to the midpoint of the opposite side. An altitude of a triangle is a segment from a vertex to the line containing the opposite side, meeting at a right angle. So we're going to take a look at what those look like on these triangles below. On number 1, 2, and 3, we're supposed to draw all the altitudes in each triangle using a straight edge. And we have one acute triangle, one right triangle, and one obtuse triangle. So we'll take a look at what that looks like here. So for number 1, the altitude, if you'll remember, meets the line containing the opposite side at a right angle. Sometimes it's also called the height of a triangle. So from point B, we go to the line containing the opposite side at a 90-degree angle, and that is our altitude. But it's not the only altitude, and that's why it says draw all the altitudes, because B didn't have to be the top vertex. It could have been A that was the vertex that we drew the altitude from. So if we did the altitude from point A to the line BC, it would come down like this at a 90-degree angle here. And additionally, if we started with point C, being the vertex we were going from, to the line AB, it would look like this. And there's our third altitude of this triangle. So depending on which side you're using as your vertex to begin from, you can create 3 different altitudes on this triangle. Notice, if we do this accurately, they all intersect at a common point. Okay, so for number 2, if I make the altitude from D to E, guess what? It's just this left side of the triangle. That's an altitude right there. And what if I make side F be the top and I go to the line DE at a 90-degree angle? Well, there's already a 90-degree angle connecting there, and that's this other side altitude of this triangle. However, if I use point E as the top side, the top vertex, and go to the line DF, this one will actually pass through the triangle, and there would be my last altitude. So sometimes the altitude of a triangle is the same as the side of a triangle when we're working with a right triangle. Now, take a look at this obtuse triangle, GHI. If I try to connect the vertex G to this line, I can't make, to this line segment HI, I can't make a right angle because it's already so slanted out that it's going to be quite an obtuse angle. That's why the definition of altitude says from a vertex to the line containing the opposite side, because it can't always go to the opposite side. So if I were to take this side HI of my triangle and extend it longer, so that it's not just a line segment, it's a line that goes on forever. Now I can come straight down from point G to this line and make a 90-degree angle, and this is my first altitude of the triangle. So on an obtuse triangle, it's quite common to see the altitude be outside of the triangle. Now, what if point I was the top of my triangle and I was going to the line GH? This is the same situation where in order to make a right angle, I'm going to have to extend the side GH beyond the line segment at that side of the triangle, make it go on forever. And now, if I want this to be a right angle from point I I make my 90-degree angle right here. So this altitude is also outside of the triangle. Now, if I'm working with point H as the top of my triangle, this is the obtuse angle, then I do actually make the altitude inside the triangle at a 90-degree angle here. Okay, so we've taken a look at the altitudes. Notice all three of these, these three altitudes, we have two outside the triangle and one inside the triangle. On this right triangle, the two altitudes are the sides of the triangle and only one altitude goes inside the triangle. Now we're going to take a look at the medians of a triangle. Okay, so the median of a triangle is a line segment that connects a vertex of a triangle to the midpoint of the opposite side. So like if I take side AC and measure it, it's 4 centimeters. So the midpoint would be at 2 centimeters. Now these are congruent, and I have those congruent marks to show this is indeed the midpoint. And if I connect point B to that midpoint, there's my first median. Now, if I turn my triangle so that point C is the top, and AB is the one that I'm putting my midpoint on. Measure this one, looks like it's about 3.4 centimeters, so we'll go halfway right here, double tick marks here, and if I connect point C to this midpoint, there's my second median of this triangle. There's one remaining from point A to the side BC. If I measure side BC, it looks like it's congruent to the last one that we did. So we'll go right here for the midpoint and connect point A to the midpoint. And if we did this perfectly, all three of these medians would intersect at a common point. Okay, so all the medians are inside. Now let's look at our right triangle. If I measure the side EF, it's 2 centimeters, oops. So put the midpoint right here. And then I create my median by connecting the midpoint to the vertex D. Now, what if I wanted F to be the top point of my triangle? If F is the top point, I measure the bottom, DE. That's 3 units long, so 1.5 would be my midpoint. Double tick marks on each side. So F goes to this midpoint to create the second median of this right triangle. And there's one more remaining. If E is the top, DF is the segment that I'm finding the midpoint for. It's nearly 4. Right here would be the midpoint. 3 tick marks on each side. And if I connect from the vertex to that midpoint, oops, there's the final median of that triangle. And again, they should meet at a common point if they are accurately drawn, which is challenging to do. Okay, on this obtuse triangle, I'm going to have, let's see, the bottom side here is about 2.4. So right about here should be the midpoint. It's going to get pretty crowded in this obtuse triangle because it's already so squished. There's my first median. Now I'm going to make point I be the top. I'm going to measure the length of side GH. And we'll do double ticks here. And finally, if we could make it any more crowded in this triangle, I'm going to find the midpoint of side GI, 4.6. Put triple ticks on each side. There's my midpoint. Connect that midpoint to the opposite vertex. There's my last median. And they all meet at a common point. So those are the three medians for each of our triangles. Okay? Now we're gonna do some practice problems. There we go. So this problem says, given that BD is a median of triangle ABC, AB is x minus 7, AD is x plus 3, and DC is 2x minus 17, find the length of AB. So this segment that I'm highlighting yellow is what we are supposed to find the length of for the answer. In order to find that length, we're going to have to solve for x. So we're going to have to write some kind of an equation to solve for the letter x. Now, remember that a median goes to a midpoint. So point D is the midpoint, which means this piece and this piece are the same. If they're the same, if they are congruent, they are equal, and equal things can be set equal to each other in an equation. So x plus 3 would have to equal 2x minus 17. And now we can solve this equation for x. Subtract x on both sides of the equation. 3 equals 2x minus 1x, which leaves 1x, or just x, minus 17. Add 17 to both sides to get the x by itself. 20 equals x. But that's not the answer to the problem because they wanted us to find the length of AB. AB is equal to x minus 7. So since I now know x is 20, I can do a substitution and say AB is equal to 20 minus 7. So AB would have to equal 13, which is the answer to this problem. Okay. The next one says, given that AD is an altitude of triangle ABC, we mark an altitude with a 90-degree angle. BD is 2x, DC is 3x minus 4, and the angle ADC is 4x plus 10. Find the length of BC. So I'm going to highlight that. That's the length we're trying to find. We're going to have to find the x first before we can plug it in and find how long this segment is. So we have to write an equation. There's nothing that we know is congruent in this picture, no equal parts, other than the fact that we know 4x plus 10 algebraically should be equal to this 90-degree angle. So that's the equation I want to write. 4x plus 10 equals 90. And now we'll solve this equation for x by getting the x by itself. So I'm going to subtract 10 on both sides. 4x equals 80. Divide by 4 on both sides. X equals 20. But that's not the answer. We have to find the length of BC. So BC is equal to 2x added to 3x minus 4. And so we can fill in the 20 for the x's here. So it'd be BC equals 2 times 20 plus 3 times 20 minus 4. So BC would equal 40 plus 60 minus 4. 40 plus 60 is 100. Take 4 away is 96. So that's the answer for this problem. Oh dear. I think y'all couldn't quite see that. I apologize. All right, next we're going to work on a proof. Okay. So the proof says, given that segment XB bisects angle ABC, that means it cuts this angle into two congruent angles. Segment BX is an altitude. Altitude means this would have to be a right angle. Prove that BX is also a median on this problem. So, for my proof, I'm going to begin with the given information. First statement is XB bisects angle ABC and BX is an altitude. I know these things because they were given. Now, when we made the statement that XB bisects angle ABC, we were able to write these angles were congruent. So let's go ahead and put that in our proof next. Angle ABX is congruent to angle CBX. And the reason that I know that is because of the definition of the word bisect. Since this is an angle bisector, it split the angle into two congruent angles. Next, we drew a 90-degree angle here. So I can say the measure of angle 2 is equal to 90 degrees. In fact, it's also equal to the measure of angle 1 because it's going to make a 90-degree angle here as well. They're both going to be 90 degrees by the definition of altitude. An altitude is a line segment which meets the line containing the opposite side at a 90-degree angle. So, I'm trying to prove that this segment is a median, which means I'd like to prove that these sides are equal. Probably the easiest way to do that would be to begin by proving the two triangles are congruent, which we've gotten a lot of practice with recently, proving triangles are congruent. Do you see anything else on this picture of these two triangles that would have to be the same? Did you notice that they have a shared side right here? BX is a shared side on both triangles. So I'm going to add that the segment BX is congruent to itself because of the reflexive property. Now I could show that the two triangles are congruent. So my statement 5, let me scoot this down for you, is going to be that triangle ABX is congruent to triangle CBX because of which one of our shortcuts? Angle, side, angle, angle, side, angle. So ASA. Since the two triangles are congruent, all their corresponding parts are congruent, so that means AX would have to be congruent to XC. Those are corresponding parts. So AX is congruent to CX because corresponding parts of congruent triangles are congruent, our good old CPCTC abbreviation. And now, since those are equal, I can say that BX is a median, which is what I'm trying to prove. That's what they told me to prove, so that's my last statement. BX is a median by the definition of median. A median is a line segment connecting a vertex of a triangle to the midpoint of the opposite side. Okay? So that one is done. Let's take a look at the next one. We have another proof to practice. Okay, this one says, given that BD is a median and BD is perpendicular to AC, prove that BD bisects angle ABC. So this is kind of similar to the last one that we did, except for that we're going kind of in the reverse order here. We're still going to begin with the given information in the problem. So given BD is a median and BD is perpendicular to AC. The reason we know those things are true is because they are given. Now, if BD is a median, that means that it is a line segment containing a vertex to the midpoint of the opposite side. If D is the midpoint, then that means that AD would have to be congruent to DC. So we're going to say that for our next step. AD is congruent to DC because of the definition of median. And they gave us that BD is perpendicular to AC. So that means these are 90-degree angles. So we'll say the measure of angle BDA is congruent to the measure, well, is equal, sorry, to the measure of angle BDC, which equals 90 degrees because of the definition of perpendicular. And you're certainly welcome to use that upside down capital T for a shortcut for perpendicular if you'd like. Like, remember this? This means perpendicular. Okay. And what else is the same in both these triangles? Well, we have the same situation we did last time. This segment BD is a shared segment, and that means it's got to be congruent to itself. BD is congruent to BD because of that reflexive property. Everything is congruent to itself. And now I believe that we have enough information to say these triangles are congruent. Triangle ABD is congruent to triangle CBD because of side, angle, side, side, angle, side. We have a triangle congruent shortcut called side, angle, side, and that's what makes these two triangles congruent. So if these two triangles are congruent, all their corresponding parts are congruent, which means this angle, ABD, would have to be congruent to this angle, CBD. So I'm going to write that next. Angle ABD is congruent to angle CBD because corresponding parts of congruent triangles are congruent. CPCTC. Now, if those angles are the same, then that means we can use our proof statement. BD has to bisect angle ABC. BD bisects angle ABC by the definition of bisect. Okay. Take a look at the bottom. it says, in each triangle, decide if segment AB is a perpendicular bisector, an angle bisector, an altitude, a median, or none of these. What I would like you to do now is pause your video and take a look at these pictures and see if you could label each one of these 6 triangles with the correct type of special segment that you see on them, or none. Okay, so pause the video. All right, I'm going to assume that you have done so. So look at number 5. We're connecting the midpoint. Oh wait, that's not even the midpoint of the side. It says this part is congruent to this part, and this part is congruent to this part. So we're not even working from a midpoint to a midpoint. We're just, I don't know what's going on here, but this is none of these. That's not a special segment on that triangle. Okay, for 6, the side AB is the side of this right triangle. But if you'll remember, we talked about how from a vertex to the line containing an opposite side at a right angle is called an altitude. Sometimes the altitude is a side of a triangle on a right triangle. Now, number 7, the vertex is connected to the midpoint of the opposite side. That's called a median. All right, number 8, vertex connected to the line containing the opposite side at a 90-degree angle. That's an altitude. On number 9, we have the line segment AB at a 90-degree angle, and in the middle of the segment, that's called a perpendicular bisector. 90-degree angle right through the middle. And on number 10, we have these congruent angle marks, which means segment AB split that angle A into 2 smaller congruent angles. That's an angle bisector. And that is all of them. So some things you might want to think about is that a perpendicular bisector, you're going to see a right angle box, and you're going to see tick marks showing congruence. On an angle bisector, you're going to see the congruent angle arcs. On an altitude, you're going to see a right angle box. On a median, you're going to see the tick marks showing that it's going to the middle. And none of these may just have some random things like number 5 did that don't really work out to any of these. Okay? Well, good luck on your assignment. Please let me know if you have any questions or need help, and have a wonderful day.